along AB with a constant velocity 3 meters per second. The wavelength is lambda and d very much capital D and d very much greater than lambda. Find the velocity of central maxima. Central maxima will be there initially here. He's asking what is velocity of this central maxima. There'll be other order fringes. At that instant is asking. Call this distance d1. In the end, we'll substitute d1, d2 value so that we'll get an idea that the velocity of that center of mass depends on what all parameters. So when you displace this, this is screen. So let's assume that the source will be here. Yes, this is S1, S2. Because as it starts moving, it will get displaced, the source. So this is the thing, that one. So now array what happened? Will arrive, and this will be the ray from source S will enter slit after diffraction. Let it be at point B. So let this be equal to Y. If you can remember directly, you can write down the expression like I told you, like, so let this be equal to A. This we took L, no, and this distance is D. So this will be delta x2, this will be delta x1. So path difference, so this should be equal to the net path difference. The equation will be delta x2 plus delta x1. Like previous classes, what we discussed, delta x2 should be equal to dy by capital 2, and this should be equal to d a by d1, and this should be equal to n lambda. We are searching for position of maxima. This like previous class, what we discussed, directly I'm writing it. So let's do one thing. Let's get expression for n lambda d2 by d1 minus, this will be a d2 by d1. It's asking to get the velocity of central maxima. The central maxima also will get displaced, no? If you move the source up above the axis, where the central maxima will be? Below the axis or above the axis? Below the axis. So central maxima will be located here. So central maxima got displaced, no? This will be at this instant. Now the source is having velocity. The source, it is having velocity. At this instant, now what is the velocity of center of mass? We have to calculate how to bring that. So what is the velocity of source? So velocity of source is what? Velocity of source is what? dA by dt. Shall I write? Because when the source gets when the source gets displaced, then it will acquire velocity, no? So dA by dt is what? The velocity of source. So what is this quantities n lambda d2 d1? They are constants. There's everything. This will output n equal to 0, central maxima. So y2, okay, I'll do one thing. Put n equal to 0. Lambda capital d capital dt d2 by d1 minus a d2 d1. So this is equal to a d2 by d1. I'll differentiate this dy by dt, dA by dt. dy by dt is what? Velocity of central maxima. Then dA by dt, velocity of source, negative sign, d2 by d1. What do you mean by negative sign? It's the center of mass will be moving vertically down. Its velocity will be directed vertically down. Okay, that should be our answer. Like this, I think now you can bring the SHM problems. If the source oscillates normal to the axis, then what is the equation for SHM of the central maximum or other thing? I think you can take help of this. If the source oscillates horizontally along the axis, if the source vibrates normal to the axis, like it's execute SHM, then we can introduce some SHM in Ydse. That we'll see tomorrow. Okay, all of you. So maximum, please try to don't spend time with MS Teams. It'll be waste of time. That one you have to only download thing and come out. If any data is there, check it and leave it that one. So these things I'll post in the MS Teams and also in the WhatsApp group. All the class notes, you can take it from there. Okay, thank you all of you.